Hello class, this is a continuation of combinations part 3. In the previous video we saw how we could prove these two styles of identities. That's 1 and that's 2, and hopefully that will give you some sort of guideline to solve those first two identities. In this video I will admit this last one is a lot harder to prove, so let's get straight into it and pause whenever you need to understand it a little bit further. So let's go. Let's first look at the left hand side and just organize it so that it follows that definition there. So 20 choose 5 is equal to 20 factorial over n minus r, that's 20 take away 5, 15 factorial times 5 factorial. That's our left hand side. Now for our right hand side, this is rather complicated, so let's do some color coding so you can see the work that I'm going to be doing. That 19 choose 4, let's organize it like so. 19 factorial over 19 take away 4. 19 take away 4 factorial is going to be 15 factorial, 4 factorial. I'm always going to point out that definition there again. So there's that 19 factorial, n minus r, so that's 19 take away 4, 15 factorial, times that r factorial. And we're done with that first one. Color coding this once again. That one is going to be 19 factorial over n minus r, so 19 take away 5 is 14 factorial times 5 factorial. Now here's where it gets rather difficult. Let's think about the denominator of these two. Now with regular fractions, we want the highest common factors. Okay? Oh, sorry, lowest common multiple. I want you to think about this. Between these two, which one is the lowest common multiple? So 14 factorial, if we write it out, is equal to 14 times 13 times 12, etc. 15 factorial, well, that's 15 times 14 factorial. So 15 factorial is the lower, it's a common multiple between these two. So it's going to be 15 factorial. So these two are going to become 15 factorial. Likewise, these two, for the exact same reason, are going to become 5 factorial. Okay? So now, just to compare this, in case you're still confused, let's say we had two fractions, doesn't matter what they are, something over 3 plus something over, let's say, 6. Between the two, they're both going to become 6 because, well, this one's already 6. This one just needs to multiply by 3 to become a common multiple. So in the exact same way, 15 and 14 factorial become 15 factorial, and 4 factorial and 5 factorial become 5 factorial. That's the lowest common multiple. Now, actually, let's keep this example here. Now, think of it like this. For 6 to become 6, nothing happens. But for 3 to become 6, it has been multiplied by 3. Well, whatever we do to the bottom, we do to the top. So now, This denominator, how did it become this denominator? Well, the 15 factorial is already there, but 4 factorial, how did it become 5 factorial? Well, it just needs to be multiplied by 5. So since we multiplied that by 5, we multiply this by 5 as well. Now watch how I'm going to write that. It's going to be 5 times 19 factorial. Okay? If you have any questions, you can ask me in class, but just hopefully you can see that 4 factorial to become 5 factorial was just multiplied by 5. In case you don't see that, 4 factorial is 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. For 4 factorial to become 5 factorial, we just needed to multiply it by 5. Hence, we multiplied the top by 5 as well. Using the same logic, I'm going to keep that plus there. Using the same logic, how did 14 factorial become 15 factorial? Well, it was multiplied by 15. We don't need to do anything for the 5 factorial because it's already 5 factorial. So, we multiply the bottom by 15, we multiply the top by 15. 15 bracket 15 times 19 factorial. Now, it may not seem like it, I'm going to take the common factor out of 19 factorial. So I'm going to write it as 19 factorial outside of 5 plus 15 over the same denominator that we have, 5 factorial times 15 factorial times 5 factorial. Now, in case you're wondering, if we multiply this out, we get this, and if we multiply this out, we get this expression. But then that becomes 20. That's 19 factorial times 20 over 15 factorial times 5 factorial. Well, similar to that previous example I showed you, 19 factorial, 19 times 18 times 17 times on and on and on. If we multiply that by 20, well, that just becomes 20 factorial. So the numerator is actually just 20 factorial over 15 factorial times 5 factorial, which you may have forgotten, but if you take a look, it's exactly what we need for the left-hand side. And we have proved it. That's the end of one proof. You can go ahead, pause the video and try it yourself here, because I'm going to be solving it in this same video. I'm going to be doing it a lot faster now, but hopefully you got the logic in how we did it. So here we go. This left-hand side is going to be 16 factorial over 16 take away 7 is 9 factorial times 7 factorial. That's the left-hand side. The right-hand side, using the definition of a combination, is going to be 15 factorial over 15 take away 7 is 8 factorial times 7 factorial plus 15 factorial over 15 take away 6 is 9 factorial times 6 factorial. The lowest common multiple for the denominator is going to be 9 factorial and 7 factorial. So 9 factorial, 7 factorial. For 8 factorial to become 9 factorial, we need to multiply it by 9. So 9 times 15 factorial. Likewise, For 6 to become 7, we need to multiply it by 7. 7 times 15 factorial. Factoring out that 15 factorial, 9 plus 7 over 9 factorial, 7 factorial. 9 plus 7 is 16. Whoops. Which, if we now just simplify, 15 factorial times 16 is 16 factorial over 9 factorial, 7 factorial, which is equivalent to what we started with the left-hand side. So, I hope that gave you an insight into how we manipulate the definition, or the definition of a combination to do some proofs and identities. In the next two videos, I'll be showing you how we can prove these identities without any numbers, and we're using strictly the definition of a combination. So I hope to see you then. Best of luck.